Hey class, so here's my attempt at a first video, and I'm actually using some new software with this, so bear with me. But anyway, some of you had questions on the homework number 7, problem 8, the one with the Ferris wheel going around. And thank you for those of you who have asked me about it, that way I could know to make a video. So in this case, what we're asked to determine is what the upward force, or what we would call the normal force, from the seat is on the person, both at the top and at the bottom of the carousel. So in order to think about this, we need to draw a free body diagram. Okay, so let's start at the top. So at the top, what would a free body diagram look like? Well, the person has their weight going down, which weight, remember, is mass times gravity, and then they have that normal force going up. Okay, that's what's going on at the top. And what about at the bottom? So at the bottom, your free body diagram will look very similar. You got the weight going down, and that's a G, and you have the normal force from the seat pushing up. So far it looks like everything's going to be the exact same, right? But that's not the case, okay? And the reason for that is because of the direction of the centripetal acceleration. As you can see in the picture, at the top, your centripetal acceleration is down towards the center of the circle of rotation. At the bottom, it is up. So if you want to add your forces at either of those two locations, what you need to do is pay close attention to the direction of your centripetal acceleration. So if we start at the top, the sum of our forces, the net force, we know is equal to the sum of the forces is equal to mass times acceleration, right? So if we're up at the top, what we have is we have our normal force, which is in the positive direction, and we have the weight force, which is in the negative, so minus mg, and that's going to be equal to mass times our acceleration, but our acceleration is down, so it would be minus acceleration. Okay, so doing algebra to solve for the normal force, which we're asked for, the normal force is going to be equal to, you add mg to both sides, and so it equals mg minus mass times centripetal acceleration. And let's just remember, what is centripetal acceleration equal to? From class, and actually right here you can see it, it's equal to the speed squared over the radius, right? And we're given the speed and the radius and mass all in this problem. So the normal force would be mg minus mv squared over the radius. And so we know all of these different variables here, m, g, m, v squared, and r, so we can solve. That's what you would want to do for part A. Alright, so you do the solving, you get a beautiful number for your force normal. I'm not going to give you the number, I'm going to let you do it, but force normal equals something, and then boom, box worthy, yes. So that's all for part A. Then in part B, I'm going to move down here just a little bit. Okay, so for part B, we're asked to determine what's going on at the bottom. So again, we're going to look at sum of our forces being equal to mass times acceleration. Okay, but now we have our normal force still in the positive direction, and we have minus our mg value, and we know that's going to be equal to mass times acceleration again. Okay, so this looks very similar to what we had before. This is our centripetal acceleration, but if we look up above, if we look up here, right, it's a negative ma, and down here it's a positive ma, and that's really the difference in what we're dealing with. Okay, so now you go ahead and solve for the normal force, and you can see now the normal force is going to be equal to mg plus mv squared over r. So again, we can go ahead and solve based on what we have here. We know m, g, m, v, and r, so you can solve, and you should be able to get, once again, a number for the normal force at the bottom that is now different than the other one, and it should be box worthy once you plug and chug. Alright, so I hope that helps. Please let me know if you have any additional questions.